Greetings, everyone. This is Norm Jones at Brigham Young University, and in this exercise we are going to do a very simple and basic introduction to variables and how you use variables in programming, Visual Basic in Excel, or Visual Basic for applications in Excel. So the assumption is before you do this exercise, you've read the chapter on variables in the Excel VBA primer, and there you learned that variables are like placeholders where you can store information and then extract it later in your code using a simple identifier. In the context of programming in Excel, variables are very similar to cells. When you put information in a cell, it stores it, and then you can retrieve that through a formula or by referencing it in your Visual Basic code. So there's a lot of parallels to cells. So to begin with, let's look through the instructions. Write some VB code in response to the click event for the button that computes the distance between 2 points. The code should be structured as possible. First, we're going to declare 5 variables, 4 of which correspond to coordinates x1, x2, y1, y2, and then we're going to have a variable called dist for the distance between 2 points. And then we are going to initialize the values of the variables using some coordinates we've defined here. And then we're going to perform the calculation and store the result in the dist variable using the Pythagorean theorem. And as you may recall from algebra, the distance between 2 points is the square root of x2 minus x1 squared plus y2 minus y1 squared. And then we're going to show the result using message box. So we're going to do things a little bit differently today. We're going to do this first without declaring the variables, and then we're going to modify the code to declare the variables and then discuss the difference between the two. So to start with, we're going to go into design mode and then double click on the push me button, and this pops us over to the code. And so like I said, we're going to cheat a little bit, and we're going to start out just by immediately using the variables. So I need to remind myself, so it's 10 and 12.7. So we're going to say x1 equals 10 and x2 equals 12.7. Excuse me, that should be y1 equals 12.7. So that's our first pair of coordinates. And our second set of coordinates are 34.2 and 45.3. So x2 equals 4.2 and y2 equals 45.3. Let me double check my numbers here a little bit. That looks correct, not that it matters that much. And so what we've done here is one of the ways which you can declare a variable is to simply start using it. And typically you start out with something like this. This is called an assignment statement. And it's very important that you understand how these assignment statements work. When we say x1 equals 10, we are not saying, it's not a declaration like you do in math where you state that x1 and 10 are equivalent. There's a context in programming when we're using if statements, when we could say if x1 equals 10, and in that context it's the same as the mathematical expression of equivalence. But in this context, when it's sitting on a line by itself, what we're really doing is doing an assignment statement. And the way you do an assignment statement, the best way to think about it, is you take the result of the expression on the right and you store it in the thing on the left. And in this case, the thing on the left is a variable. So when we say x1 equals 10, what we're really saying is take the value of 10 and store it in x1. Now, instead of a single number, I could have said 10 times 24 divided by 7 or something like that. And that still works because, again, on the right side you have an expression, and the result of that expression is then stored in x1. That's how an assignment statement works. Or sometimes the expression could include variables, so I could say plus x1 times 2 or something like that, and that would also be a perfectly legal expression, and we would store the result in y1. Now, you would never under any conditions say 12 equals y1. The thing on the left, when you're using an assignment statement, the thing on the left has to be something where you can store information. So it could be a variable, it could be a property associated with an object, which we'll get to later in the semester or later in these videos, or it could be a cell that we access using either the cells object or the range object. And that's a really common way to take the results of some calculations in Visual Basic and store them in a cell. So in this case, we've said x1 equals 10, and what happens is when the Visual Basic compiler encounters that line, it says, well, I don't recognize this x1, but given the context of how it's being used here, I'm assuming that the programmer wants to declare a variable and store this information in it. So it dimensions a variable, and away you go. So in that sense, Visual Basic for applications is a very forgiving language. If you can declare your variables if you want. If you don't, you can just start using them, and it declares them implicitly. Now there are some disadvantages to that, which we'll cover in a minute, but for now let's just assume that's how we want to work. So we now have these two sets of coordinates, and we are ready to compute the distance between those 2 points. We're going to do that using another assignment statement. We're going to say dist equals, and in so doing we are declaring a new variable called dist for distance, and we're going to store in that variable the results of the calculation. In that calculation, we're going to do open paren, x2 minus x1 squared, and to square something we say caret 2. Caret is shift 6 on your keyboard, plus open paren y2 minus y1 close paren caret 2, and then one final parentheses around the entire expression. Then we're going to raise that to the 0.5 power to take the square root. Now there are two ways you can take the square root. You can raise it to the 0.5 power, or you can use the SQR function. So let me show you how to use the SQR function. You can go right here, SQR, and that will also take the square root. This is a Visual Basic function. It's similar to the SQRT function in Excel, and it takes the square root of whatever you pass to it in parentheses. So either of those will work, and now we're ready to display our result. We are going to write message box space dist, and that's it. The rest of the arguments to the message box object, we're using it as a sub in this case, are optional. The only thing that's required is the prompt, which is the message that's going to be displayed. Now, as you may recall, that prompt is supposed to be a string, and we are passing it a number. The result of that expression is a number. And when we pass that in, Visual Basic is smart enough. It says, well, we need a string here, but you've given me a number, so it just converts it to a string. So a set of numbers can be part of a text string, and so that's what happens. And so at this point, this should work. We're going to save our changes and pop back here, exit design mode, and push click me. And there, down here, is the result of our calculations. It says Microsoft Excel 40.6000, whatever. Okay? Great. And that all works just fine. But let's go back and look at our code for a little bit. And remember, the instructions told us to declare variables, and we didn't. And it still worked. And there are cases, lots of cases, where you can just skip the part of declaring your variables and just start using them and everything works out fine. But let me show you what the danger is. Now this is a really simple piece of code, and so it's kind of hard to mess it up. But let's suppose, just for the sake of argument, that we forgot to put the 1 on the y here. We just did y2 minus y. Now that would still work, and remember, when the Visual Basic encounters an identifier that it doesn't recognize, it just assumes that you're declaring a new one. And so when it encounters the y here, which is not referenced anywhere else, it dimensions a new empty variable. And for numbers, now we're using it in the context of a mathematical expression, so Visual Basic guesses, well, it's probably a number stored here. And it returns the value of that variable as a number, which the default value for all variables is 0. So it does y2 minus 0. So this is still going to work in the sense that the code runs, but you'll see now we get a completely different answer. The correct answer is 40.6, and now we have 51.358, etc., which is wrong. And the scary thing is, unless you went in and double-checked your work, you might think that's the right answer, when in fact, what's happened is you've misspelled your variable names. So basically, the danger of not declaring your variables is you may accidentally misspell something. Your code will run, it just gives you the wrong answer, and you would never know the difference. So how do we get around this? Well, it's kind of a two-step process. What I always recommend you do, just get into the habit of doing it, is to go to the top of your code in every one of these windows where you're typing code and type option explicit. Now what this does is it tells the compiler, basically, force me to declare all my variables. So if you have this declared at the top of your code, and then it encounters a variable that you have not declared, then it will push an error message. Now I'm going to show you a couple different ways to declare variables. So I'm going to go in here, I'm going to say dim x1, y1, x2, y2, and dist. So I'm declaring the variables that I intended to use here. Now, I haven't declared this one down here because that is, again, that's a mistake. We're assuming that's just a typo. And so now what happens when we go to run the code, we get an error message from the compiler. It says compile error, variable not defined, and it highlights the y there. So again, when you say option explicit, what you're saying is force me to declare all my variables. And if you encounter a variable that I have not declared, assume it's a mistake. And that's exactly what's happened here. And so we look at it and say, oh, wait a minute, I misspelled that. That should be y1. And when you see this yellow line highlighted here, that means that the code is still in run mode, but it's paused. And so there are certain things you can't do when you're in pause mode. So to get out of pause mode, you can either click on the reset or stop button, or you can just push on the continue button, and now we have, again, the correct answer. So yeah, that's a good indication of how and why you should force yourself to declare all your variables. Now, another thing you might remember from the reading of the chapter is that each of our variables has an associated type. And when we just type dim and then list all of our variables here, we are effectively declaring these as variants. Now, a variant is just kind of a default variable type. You can put anything you want in a variant. You can put in numbers, dates, currency, string or text string, a Boolean. And when you assign something to a variant using an assignment statement, it can tell based on the context of what you're putting in it the kind of information it is, and then it remembers that. So if you put a text string into a variant, it knows that it contains text and it behaves accordingly. And so in a way, variants are extremely handy. They're very useful. And It's kind of a catch-all. But sometimes when it's helpful to be more explicit about your variable types. For example, if I know that my variables are going to contain numbers, it's not a bad idea to declare them of a numeric type. In this case, what we'd want to use is typically would be a double. Now, for floating point numbers, that's a number that has both a whole part and a decimal part. Real numbers, they're sometimes called. You typically store that using either a single or a double. A single is a single precision floating point number. It has 4 bytes, and a double is double precision. It's good to about 15 significant figures, and it has 8 bytes. And that's generally what we use as double. So if I go up here and I say, I list all these variables and then I say as double, you got to be careful. In some programming languages, this would mean that all of these variables are doubles. But in fact, in Visual Basic, you have to define an explicit type for each variable, or it is assumed to be a variant. So what this line of code really means is I'm dimensioning x1, y1, x2, y2 as variants, and dist as double. So you got to be really careful with that. So if you want all of these to be doubles, you have to go in here and explicitly, I'm just doing copy paste here, make them all doubles. And you can split this over multiple lines. I mean, you can have 4 on one line and 1 on the other. They could each have their own line. It doesn't matter. However you want to organize this. And they don't need to be at the top of your sub. You can declare them anywhere in your code. I mean, I could go down here. I'm going to cut that and paste it down here. So you just have to declare it before you use it. And then this should once again work just fine. We'll save our changes, and then there we go. Everything's still working out correctly. So that's kind of an introduction on how to use doubles. And I want to show you one other thing. This message box is not terribly helpful to just say dist. You know, it shows that since this is a double, it's showing out to about 15 significant figures. Well, maybe we just want to say, you know, 40.6 or 40.60. We can do that using, there's something called the format number function. So I'm going to go right in front of that argument, and I'm going to type format number, open paren. And this is a Visual Basic function. The first item that it takes is an expression, which is a numerical expression. And then the next argument, which is optional, but you almost always use it, is the number of digits you want to display after the decimal. So I'm going to put 2 here, and then I'm going to, the other arguments I seldom use, so I'm going to leave those off. And so now what I'm saying is take this number and convert it to a string, and in the process round it to the second number after the decimal. And so let's give this a try now. As you'll see, it now says 40.60. And if we want to make this even nicer, we can go back to the code and say, put a little a text string tag on here. We can say the distance, let's see, dist equals, and then I'm going to do ampersand. And so what I'm doing here is I am, instead of just saying 40.60, I want to say the distance equals 40.60 or whatever the number turns out to be if you change the inputs. And again, the first argument for the message box call is a string, or an expression that results in a string. And so format number returns a string, and I want to concatenate that or combine it with the distance equals, and I do that using this little character here. It's called the ampersand character. It's Shift 7 on your keyboard. And you can also combine strings using the plus sign, but that works sometimes and sometimes it doesn't. I strongly recommend, if you're going to combine strings, use the ampersand symbol. Just get in the habit of doing that. And so now let's try this out. Save our changes again, and the distance equals 40.6. And so that's a little more useful message there on the end. anyway, that completes all 4 steps of our exercise. And so again, to recapitulate, we learned that you can declare variables implicitly just by starting to use them in assignment statements. The danger of that, however, is if you make a typo, you may end up with some incorrect calculations that are really hard to track down. And so if you type option explicit at the top of your code, that forces you to explicitly declare each of your variables. And if you happen to misspell something, it'll catch that and alert you so that you can fix that. And that's a much more robust way to go. And if you don't declare a specific type, all of your variables are variant, and there are some advantages in declaring them as the explicit type. So that concludes this particular exercise.